Hey everyone, in this video we're going to talk about homework 4 and what it is that you'll be doing on the historical build-up exercise and also in setting the requirements. Um, we covered the overall goals of the historical development and the requirements or setting the requirements in the previous videos. So I'm not going to discuss this in this video. I'm going to jump straight into talking about homework 4. All right. So there will be two parts to this homework. The first one is the historical buildup, where you will collect a lot of information on 10 different aircraft of similar category and class that you want to design. And you will use the data that you find in the historical buildup to set requirements for the aircraft that you want to design. Pretty much, you will be talking about what it is that you want the airplane to do and how you want it to do it. All right. So let's jump into the first part, which is a historical buildup. The step one is for you to determine the category and class of the airplane you wanted to try and design for. So what is class, category, and class? We covered some categories and class in the first lecture in the first week, but here are some of the examples, right? You got a lot of different categories and classes. You can choose any one of them. The neat thing is that the process that we are going through to design the aircraft is applicable for all of these type of different aircraft, and you don't necessarily have to pick one. Um, you know, the entire class doesn't have to pick one type of an aircraft to design. All right. But I do have to warn you that maneuverable airplanes and supersonic airplanes are much harder to design. It's not impossible. You just have to do a little bit more work in order to predict, how the performance of the aircraft under high maneuvering conditions and also in supersonic. Because as you go supersonic, well, you have to account for the compressibility effects. In other words, the shock waves, and you have to like calculate how the shock waves will affect the performance of your aircraft, both again in subsonic and in supersonic conditions. So it's again just FYI, but it doesn't mean it cannot be done. It just takes a little bit more work. All right. So the step two is once you have selected a category and class of airplane, you must run it by me for approval. Please make sure to do that before September 15th or on or before September 15th because you need to be spending a lot of time on collecting the data. Okay. So after you run the category and class of airplane that you want to design by me, you immediately jump into step three, which is you have to choose 10 different aircraft of similar category and class, to compile as much history as you can. Okay, so now we'll talk about what that history is that you want to collect, but you gotta be able to identify 10 different aircraft. For example, if you're designing a fighter, you look at all the fighter aircraft that exist, right, F-14, F-15, all the some of the F-series aircraft, then you can identify and you can basically like collect data on and be able to identify, if there are any gaps. All right. So the step four is basically the prime of the assignment because this is where you'll be spending a lot of time on. All right. You'll be collecting specifications or specs on performance, aerodynamics, mass, propulsion, fuselage, and landing gears. Right. This will take time, so make sure to start the assignment early. All right. Now I'm going to walk through the different parameters that you can collect, but just know the goal is to try obtain as much information as possible, but again, I can guarantee that you won't find all of these information for all 10 aircraft that we're going to talk about, right? More often than not, you may have to make some very good educated assumptions, right? And some of the parameters that we're going to talk about may not even be applicable to the aircraft that you want to design. So it's up to you to choose a good chunk of these like variables, these parameters that where you can actually collect data on and use it to plot some trends. Okay. Um, again, that doesn't mean just don't just collect two or three of data in each categories. You will rely on this data a lot more than you think right now. Okay. So and because this will essentially form the basis of your semester long aircraft conceptual sizing process. Every time you get stuck, you will have to come back to this, and you better have data to support you. But that's why we're offloading all the work beforehand before we jump into like making estimations of the different design decisions. Okay, so make sure to spend a lot of time. That's why you get more than I would say more than 2 weeks to do this assignment. Please make sure to use that time wisely. This is not something you can do a couple of days before the assignment is due. You can't possibly do that. So make sure to get a head start. All right. So let's talk about the specs that you're going to collect. We're starting with wing aerodynamic specs. Well, it's basically essentially everything about the wing itself, right? So we got the wing airfoil profile, camber, CL, CD, area, span, aspect ratio, mean aerodynamic chord, loading, sweep, taper, the heater and heater wing incidence, CD0, and that CD0 can be an entire aircraft CD0 as well. Wing location from nose, wing location, the percentage of fuselage velocity at cruise, right? These are some of the data you can collect for wings related to wing aerodynamics. Similarly, you can collect data for tail aerodynamics where, you look at the area, the half span, mean aerodynamic chord, aspect ratio, taper ratio. Um, so HT versus wing area ratio, that means that what percentage or what ratio of the horizontal, of the wing area, is equal to the horizontal tail. So, it's just you comparing the horizontal tail area to the wing area so that you can size your tail right. Right. And the moment arm is important as well. What is the distance from the, say, aerodynamic center of the tail, to the CG, and then the tail volume coefficient as well, right? Now we'll talk about what that is. And then the incidence angle is important because sometimes depending on where your CG is, what type of aircraft you have, the tail may be positioned at a certain incidence angle, right? Whereas VT incidence angles, it should be zero, right? You basically collect the data for both his horizontal tail and vertical tail. Right, and then you move on to highlight devices. More often than not, you have flap or leading edge slats or slots to augment the lift created by the wings. So it'll be good for you to have an idea of what those specifications look like. But also control surfaces are important as well. Right, you got the aileron area, rudder area, elevator area. If you have trim tab areas, you can include that as well. Again, the flap span fraction, like what percentage of the span is taken by flap, and aileron span fraction as well. And if you have spoilers, you can include that as well, right? Moving on to mass and CG specs. Well, you look at the max takeoff weight, landing weight, empty weight, fuel capacity, payload weight, propulsion weight, structural weight, and you will basically mention all of this in terms of fraction. So like empty weight fraction is basically like empty weight divided by the takeoff weight, payload weight fraction, fuel fraction, propulsion fraction, structural fraction, because you need to make some really good estimates for all of these when you're designing your aircraft, and having a really good like database of these values for similar category in class will reduce a lot of time, okay, in the long run. So you also be looking at the CD location from nodes and the static margin. So we'll look at how we can calculate static margin and the CG, but this is something that you really, really want to collect. So moving on to propulsion and specifications, well, you got to look at the engine power, the engine number, prop diameter, number of blades, blade pitch angle, engine location, fuel consumption, specific fuel consumption, 1/over specific fuel consumption, thrust/power loading. All right. So then fuselage and landing gear specs, well, we get the fuselage length, diameter, fineness ratio, reference area, aircraft height, main landing gear location from nose wheel location from nose. Again, this will go a long way in designing your fuselage as well. One of the most important aspects of this collecting a specification is basically the performance, because performance will let you, set the requirements as well. Okay, so basically you got to think, you got to look at cruise speed, cruise altitude, cruise power, max speed, takeoff distance, landing distance, service ceiling, no flap stall speed, flaps, stall speed with flaps, takeoff speed, landing speed, rate of climb, normal range, max range, endurance, roll rate, max G loading, min G loading, turn radius, etc. Right? There's a lot of performance specs, that you may need to collect data on, but not all of them are as important as
as with each other, because it really depends on what type of aircraft you're designing. For example, like, for a commercial airliner, roll rate may not be that important, but for a fighter, roll rate is very important, right? So you got to make sure to collect that data, okay? And if you're doing some aerobatic aircraft, the max and min G loading is also important, correct? So make sure to identify what is that's very important to you, and you have to collect that. But cruise speed, cruise altitude, landing distance, no matter what, you need those for all type of aircraft, right? So the goal here is to, again, collect some good chunk of these data, so that you'll make a very informed decision when we're going to set the requirements. All right. So the next step after you collect all the data is to tabulate the parameters you find in good tables for all 10 aircraft. You can have tables for performance, for fuselage, for propulsion, mass, highlight devices, and aerodynamics. Right. So you get, like, 5 or 6 tables there with all the parameters listed. That's so that it allows you to see the data as well as allows you to plot it pretty easily too, which is basically the next step. The intention of collecting all this historical data is to plot some of them and in an effort to identify the niche that may exist or gap in existing performance, right? And you will be designing your airplane to satisfy that niche, you know. So depending on what aircraft that you're looking at, these are some representative plots that you can plot. Range versus payload, fuel weight fraction is a function of range, cruise speed as range, aspect ratio versus range, thrust to weight ratio is cruise speed, you know, but just don't stick to these five, okay? You really have to identify, what parameter is of most interest to the type of aircraft that you're designing, okay? Um, right? So again, as I said, these are just representative plots. You must identify the parameters of interest for the aircraft designing and plot them to identify the trends. Um, right? So it's very important for a long range aircraft. Endurance will be more important, right? The flight time will be more important. So you may have to plot that versus like payload, or like um, you know takeoff weight, right? So the goal here is you have all the data. You just have to find what's important to the aircraft and plot them in such a way that you can identify the gaps and the niche that exist. Okay. Um, Again, if you have any questions on this, please make sure to let me know. All right. The last step is basically you will use the niche to design the aircraft for the semester. And by the time you get to this step, that niche should be really obvious from the data you collected, qualitative and qualitative analysis of the trends you observed in the parameters of interest and the associated discussions. Okay, so make sure by the time you get to this step, some of those like niche, some gap are obvious. Okay, and that's pretty much marks the first part of the historical buildup. The second part is you will use those gap to define functional requirements for the airplane. Basically, you'll be selecting what, you'll be determining what do you want the airplane to do, and you'll be drawing a mission profile for your aircraft. Okay. Step two is based on your mission profile, set design technical requirements from the historical data, right? You use historical data to do it for your aircraft at various stages of the mission. Tabulate all the requirements in a table for different mission specifications, right? What do you want the ground roll to be? What do you want the takeoff distance, the climb rate, and all that to be, right? So you have to identify those set of requirements. Step three is, you have to identify any regulatory requirements set by government organization for your aircraft. If you're doing civil aircraft, make sure to look up 423 for utility, aerobatic, and commuter category airplanes, and 425, for transport category. So if you just Google 423, 425, you will see the document, right? So federal aviation regulations, I think, that you should, or I think it's federal airworthiness requirements or something like that. So you make sure to look that up. For military aircraft, you may want to search some of these documents, right? So I pulled this from Nikolai's textbook. So if you Google some of these, you may end up finding some of the standards and the specifications. More importantly, here's a document number, right? And the documents that the corresponding documents that's associated with that document number for military aircraft. So make sure to check this out. Make sure to find the relevant specification and the requirements set by the government, and make sure your requirements abide by those rules, right? The step four is basically you identify all the systems you need for the aircraft to successfully complete the mission, right? Again, airframe, propulsion, like, GPS if it's necessary, etc., right? And step five, the design criteria for the aircraft. So what are all the design criteria for the aircraft you want to design? Rank the criteria in a decision matrix, right? If you are designing commercial, stability may be an important factor, um, right? If you're designing a fighter, something else may be a design decision, like, important factor. So you really have to identify what really is just the important factor to you, and you have to rank the factors in a decision matrix, and you will use that to in your design as well, because if something is important to you, you will make sure to get that out of your design, just like how we talked about the Marine One helicopter, that should be aesthetically pleasing, um, right? So you want to think about what it is that you want the airplane to do and what is more important for the airplane. And this is not something that is, you know, that's common, right? It really differs for different types of aircraft. That's why, I'm struggling to give a specific example, because it really, really depends on what type of aircraft that you want to design, right? If you want to design, aircraft just for like aerial viewing, well, unobstructed view of, of the ground, or of the terrain is of utmost importance, right? So you may have to design your airplane based on that, um, right? If traveling several ranges pretty, very important to you, then you're gonna have to make sure that is your utmost priority, right? If radar cross section, minimizing radar cross section is a priority to you, you may have to set that as a criteria, right? So that you can shape your airframe based on that. So there's a lot of like things to think about depending on the type of type of aircraft you're designing, right? And that's something you will find out once you do the historical buildup. Okay, so that's basically all the 5 steps. That's basically the first and second part of homework 4. So again, I urge you guys to start early. Make sure that you set daily goals towards accomplishing some aspect of this homework, so that you won't be overwhelmed when the due date comes closer. Okay. I repeat, this is not something you can put it together in a couple of days or even 3 days. You really need to make use of the next 2 weeks. Okay. All right. Well, let me know if you guys have any questions.